I'm going to really quickly clean my data here. I just imported the variables. I'm going to delete this row and I want to freeze that top row like that. Now let's go ahead and do a sort. I need to get rid of my negative values. I just went to the sort and filter there. Let's do Mother Ed first. Okay, all these negative 9s, I'm scrolling down on the far right there, holding down Shift, selecting those. Notice I'm deleting everything that's in those rows. And I may just take a peek there at what my highest values are. Okay, those are looking good. And then looking over at the F3 SES, so this is their socioeconomic status when they were in their mid-20s. I just keep going over to sort and filter custom sort. I know that's off your screen there. Let me just go smallest to largest. Now, this could have negative values. This is a standardized score, a z-score, but I know from looking at the code book that the -8s and the -4s are missing values. Once we start with these decimal, those are legitimate negative z-scores. So I'm just deleting those off. Let me just take a peek, make sure that my highest values there in F3, yeah, I mean this clearly is a pretty wealthy student, 11 standard deviations above the mean, but it's a legitimate score. Okay, now I need to run a regression analysis. When I go to data, sorry, I had to expand the screen there. Data analysis is what I'm looking for. It's possible you won't have that showing up, so let me show you what you need to do if you don't see it. You'll go to File, and then Options, Add-ins, and this analysis toolpack, not the one that says VBA, just this top one here. And instead of OK, you're actually going down here and pressing Go, making sure that's checked, OK. And then it should show up there. And to run the regression, we highlight it, find the word regression, OK. Input our Y range. So this is the variable we're trying to predict. In this case, the socioeconomic status in their 20s. I like to go ahead and use the, you know what, let me see if this works. Control down should put me at the very final cell. If I do that, go all the way to the top and press Shift, I can get them all in there. So that's going to give me all of my Y values. If you just select the column, it works in Sheets. I don't think it works in Excel. Now I'm going to get my X range, similar thing. Control down gets me to the last cell. Scroll up with the scroll bar and hold down Shift so I capture everything. It automatically goes in there. I do have labels, that's these top labels up here, and I'd strongly recommend keeping those in just so when the output is there you can see what's what a little better. And let's just do a new worksheet apply. Residuals are going to tell you how far off each data point was from its predicted based on whatever the mother's education was, but we're not going to look at that. And confidence level, if we wanted to, 95% would be a good one to go. Basically, we're just hitting OK here. Okay, what I'm going to do here, select all these columns, expand one of them, so that'll expand all of them. And now I can see my output here. So wow, what do I do with all this? Let me show you some key places to look. First of all, there's 3 basic sections. So you have your overall output, you have what's called ANOVA, this stands for Analysis of Variance, and then you have what's called like a coefficient section. This is really working with your regression equation. So this is essentially giving you your effect size, practical significance. This section is giving you your statistical significance, and then this will give you your actual regression equation or prediction equation. So let's see if we got a statistically significant result first. What we're going to go to is this significance F there. this is essentially a p-value. You can think of it as a p-value. So we're looking for something below 0.05 traditionally to see if our overall prediction model was significant, was statistically significant. With a data set of this size, you're almost always going to get statistical significance. So you might wonder, well, we have 5.32 here. This is way above 0.05. Not quite, because we have this e negative 229. What this is 5.32 times 10 to the negative 229. In other words, it's 0.00000, do 228 of those zeros and then a 5. So we're well below the 0.05 threshold. So we would say that this mother's education is a significant predictor of the socioeconomic status. Is it a practically significant one? Here's where we look up at our R squared. This is our Pearson's correlation coefficient R that we've talked about. This, we don't know if it's positive or negative just by looking at this. We could look at the sign right down here to tell us. Since this one here is positive, we know that our multiple R is also positive. This is the slope of our regression line, by the way. So the sign of the slope and our R value should always be the same. So this is really positive 0.28 R value. If we square that, we get our R squared, which is an effect size. What we'd really like is our adjusted R squared. The difference between these R squared and adjusted R squared, the R squared is based really on our sample that we are looking at. The adjusted R squared takes the variance in our sample and tells us what we think the effect size would be in the actual entire population. And that's what we always care about in inferential statistics. So here we have 7.9%, right? If we shift that decimal over, so almost 8% of the variance in socioeconomic status is somehow connected to mother's education, which is a fair amount, maybe small to moderate effect size in this case. Of course, that means 92% of the variance is related to other things, which is another way to look at it. Let's take a look then down here at these two numbers. So this gives us the intercept and the slope of our regression equation. In other words, if we want to predict someone's socioeconomic status in their 20s based on knowing what their mother's education is, we could use the equation F3 SES equals, and we would put a slope in there, so say negative 0.33 plus that 0.1065 times, and then whatever their mother's education level is. And that's how we would write it. If we actually wanted to calculate it, of course we would have to do a formula, which means an equal sign, and then we would just click this cell plus whatever the slope is times, I'm forgetting the values here, but let's say whatever that mother education scale is. Let's say someone had a 3 on, I forget if that's graduating a 2-year degree or something. We'd have to go back to the code book and take a look. But I press enter now. I can see I'd be just a hair below average in terms of socioeconomic status in the mid-20s. That's what we would predict based on the mother getting that far in school. Okay, I couldn't resist. I'm teaching you all about how stats needs to be relevant. So now I'm curious what the actual values are. So I went to my code book, did a search for by mother's ed. So a 3 was attended a 2-year school, but there was no degree. A 4 was graduated from the 2-year school, attended college, no 4-year degree, graduated from college. Since you're currently working on a bachelor's degree, You may or may not be a future mother, but let's go ahead and plug that in. So we saw that attending a 2-year school without a degree put the prediction at slightly below average in terms of the socioeconomic status in their 20s, the child's socioeconomic status. So let's take a look at what happens when we plug in a 6. We say they did graduate from college. So I'm using that same formula, except now instead of a mother's education level of 3, I have a level of 6. Notice that that predicts now that the child will be 0.3 standard deviations above the mean. So yeah, not real easy to interpret that, but a couple steps above average in terms of socioeconomic status in the mid-20s. Now we do have to be careful. This doesn't hold for one specific person. Actually, it is still our best prediction if, say, you're a mother and you're wondering the predicted value of your child's future socioeconomic status. However, when you're dealing with a single person, the variance on this is fairly high. If we're dealing with a average group, so on average, students whose mothers had a bachelor's degree, then the variance is much smaller, and this is a fairly accurate prediction. Again, going back to the R squared, the higher the R squared, the more accurate this prediction is.